Okay. On most of the level computer, you can see this is the program to helping you set up your oscilloscope. Okay, and that will be display on your desktop. So the first thing here, if you say you want to set each window to design channel, then you can type number 1. Okay, and that will be telling you thread, auto set, then measure. Press top button, then select the source. Then you press each window to design what channel. Okay, channel 1 or channel 2. And now, if you say you want to set a scope probe to match your probe, then you press number 2. So they say press channel 1, menu, or channel 2, menu. Press the button to change on the probe window. You understand your oscilloscope probe setup have to be matching with your scope probe by 1. Both have to be by 1 or by 10. But both have to be by 10. That means everything here, okay, is how to set coupling, AC/DC, set the measurement, use cursor to measure the time, or use cursor to measure the voltage. Only one thing, do you know what number 7? They say measure unround voltage. Normally, you want to using the scope to measure voltage. They must expect to the round. Okay, that means you connect into a certain point, and the scope probe must be round. And now, if you want to measure between point A and point B, it's not rounded. How can we measure? That will be number 7. Okay, then you can see what's going on here. See that? They say set both channels at the same voltage. Press the match button. Press channel 1 minus channel 2. Then you can press the cursor button. In the type window, select voltage. In the source window, select match. Move the cursor to the measure match voltage. Read data in the delta window. That is a step by step by step.
Mr. Pham.
In order to get able to measure 2 points without the round.
Mr. Pham?
Yeah.
I just wanted to point out to everyone, when you're using this method, when you're on the lab volt units, it will specifically tell you to use the add/invert method.
Okay.
That's what they're talking about.
Okay. Yeah, I understand. Now, this what we're talking about, the scope we're using in the lab. Okay. That means number, I think, 2110, 210. When you're talking about add inverted, right? That means they're talking about using the analog scope. analog scope, they don't have this kind of function. You don't have a subtract channel 1 to channel 2. So if you want to do the same, then you must be add channel 1 to channel 2. However, you have to converting channel 2. Then there will be a subtraction. That using analog scope, not in the digital scope we get in the lab.
Okay, thank you.
Yeah. Will be sometimes some will be forcing your guy to using analog scope. The reason is some company they keep using analog scope. They don't want to update the oscilloscope. The reason is the scope still get the job done. Why they want to get a new one? However, good. Okay, so that's why we have to update it.
So, Mr. Pham, that pertains to number 3, right?
What do you mean number 3?
What you were talking about, because you said it was an analog scope. So and then you press the button on number 4. Does that pertain to 3 and 4?
No, this is apply only for digital scope. Don't using this for analog scope.
Okay.
I will be make another program for analog scope. So no matter which scope you want to use to get your job done. However, this digital scope more easier. Analog will be need more, time.
Okay, so all these instructions that you give, once again, it's for digital only.
Exactly.
And then in the future, you'll give us another set of instructions for the analog.
Exactly.
Okay, thank you. Thank you very much.
Yeah, the thing is you're supposed to better know both. Otherwise, you get into the company that using analog scope. What can you do? Okay, more exercise on the scope and later on, no big deal, not a problem. Okay, make sure on the desktop of the computer in the lab, they get the icon for OSC help. Double click on that, then you can see this is the program to helping you to do it without open the note. Okay, any question here? Any question about the lab schedule for this week? Okay, so no problem. Okay, we go back.
I do, Mr. Pham. Sorry. I received an email last night saying that I'm cleared to go, but I'm not in your list.
Okay. Let's see. Hello, Mr. Pham. Hello, Mr. Pham.
I went to the school and got my
Okay.
test, weekly stuff.
Okay, Mr. Pham, can you take the name of this student? He said he already ready.
And I took another test yesterday, so I should have it today or tomorrow to upload it.
Okay, so hello, Mr. Pham.
Somebody somebody, what? Just saw something on the text.
Just a minute.
I will go ahead and send my results to Karen King, I think was her name,
Exactly.
just to verify.
Yeah, that's what last time I already showed you.
And I did, so I will check with her again.
Okay. Tomorrow, to the left. Just call her. She said, okay. You go to the left.
Okay,
And then we will be set it up for you. The left.
thank you.
Okay. Okay, so just wait for me. I need to share my okay. Let's see. Before we go into electronic again, I want to make sure you understand on that one about the DC. On the DC, we get the voltage divider law. Okay, voltage divider law using a lot. And this will be using to calculate the voltage. Apply only series. Series circuit. Okay, now I given you this circuitry. Plus minus E, R1, R2, R3. This is point A, B, and C. Okay, I just review. If you want the total resistance, then you get a total R1 plus R2 plus R3. More resistor in series, keep add them up. If you want to calculate the current, V or E, sorry, we're using E. Divide R total. Okay, now, if I want to calculate the VR1, you understand that will be I time R1. VR2, I, R2, VR3, Okay, if I want to measure the VB, what VB equal? That means I want to measure the voltage from V to the ground.
E plus BR1
If I want to measure
minus I times R1.
how do we get VB? Basically, you take V okay. Let's go up me. Okay, anyway, VB will be equal VR2 how come screw up my I don't want this. Okay, let me get out this guy. How you can display a second one here?
We got a troubleshoot.
Now, who else now the iPad can help me out? This is the first time I get into that problem.
Anybody else on the air know anything about the iPad to help us to fam out?
Let's see, I can go. Okay, let's see, what can I do?
Mr. Pham,
Yeah,
you said it's on iPad, right?
yeah,
Okay, let me go check in this. Let me see Zoom. Zoom mode. Okay, exiting Zoom mode on iPad. To turn off Zoom, go to setting.
You mean Zoom to setting what?
Yeah, this one they said if you go okay, go to setting and then go to accessory and then go to Zoom and tap to turn Zoom off.
You mean on the iPad?
Yeah, so this is what I got from the web page. I did a search and that's what they tell me. Okay, exiting Zoom mode on iPad. To turn off Zoom, go to setting,
Okay,
accessory, Zoom, then tap on turn Zoom off.
okay. Now let's see. Let's see. Turn off Zoom.
Yes.
Accept. See Zoom, then tap on turn Zoom off.
Yes.
That means I go to my iPad, right?
Yes.
Let's see. I want to get out this Zoom.
Let me go ahead and close this. Stop the sharing for now. Okay, there also, let me see, for iPhone. Okay, so this one, this apply to all iPhone, iPad, and iPod. So they said you must double tap with 3 fingers to enter the Zoom mode or exit Zoom mode.
Yeah, I already exited now.
Okay,
So I go to setup for the iPad, right?
yes, sir.
Okay, I see it where to set up here. Setting up. Okay. Zoom. So
And there should be an option set to turn Zoom off or Zoom on.
no. They just get photo, microphone, camera, so like that.
No. Okay. How to fix iPhone stuck in Zoom mode, unlock it. Let me see. How to fix Zoom out iPhone, how to turn off. Disable Zoom on iPhone. Let me see, zoom in on the iPad screen, Apple support. Just magnification, double tap the screen with 3 fingers without lifting your fingers after the second tap. Then drag up or down or triple tap. Okay. Have to fix iPhone show magnify. Deactivate it, it will also stop. Okay, you must never want to zoom to your class. Okay, so
This is the first time I get into this problem.
right.
Never know. Everything in other applications there. Info.
So Sabrina got a suggestion. She said you can double tap the home button to get the thumbnail of all the windows and close the program by swiping up on the thumbnail.
On the iPad,
Yes, she said you can also double tap the home button.
home button.
Yes, and then it bring up all the thumbnails of all the windows and you can close some of those windows. And so that's to exit.
My home here.
So press on the home button twice quickly.
No,
No,
it did not do anything.
okay. pinch into zoom gestures. Okay, so zoom feature off. Zoom out, you can zoom, magnify, deactivate will also stop it from being actually turned on. To switch it off, open the setting. Okay, so share. So this is the other one, that suggestion.
For accident, press into certain.
Okay, so right here, number 4, turn off zoom feature off. Okay, deactivate it from being actually turned on. To switch it off, open the setting app.
Okay.
Go
You go to setup, right?
open the setting app, yes.
Okay, go to,
And then click on the general, go to general.
okay, let's see. General.
And then the next one, it should be accessibility.
Okay, general.
Yes.
Okay, software update. No, that's okay. No.
You should get a tab set accessibility.
Okay.
This one right here.
No, they don't have a that option.
Oh,
It's
okay.
spelling enable. Tactical keyboard.
So they have, yeah, so they have 3 options. So one of them is on top, that's a double tap, so this one double tap the iPad.
Okay, so that's okay. I can fix it later.
Okay, so here's on Zoom, you can also watch on, here's,
Okay, I'm glad you put it.
okay, yeah, that's just closing the app. So let me see. Turning off the Zoom features on iPad. Okay, how to enable and disable Zoom for iPad. Okay.
Hello, Sam.
Yes, Miss.
Okay. I will be using the laptop for now.
Okay, okay.
Otherwise, we spend too much time.
Yes, sir.
Okay, thank you.
You're welcome.
I will fix that later. We don't have much time.
Yes.
Okay, so we have to say voltage divider. Okay, now we go into electronic. Last time we already talking about the Zener diode. Okay, so can you see it?
Yes, we can see it.
Okay.
Yep.
So basically that is the key point. Okay, on this thing here. This is a symbol for the Zener. Okay, and the Zener, they can be working at the breakdown, or they can be working like normal. The key point is when they're working at a breakdown, you're not using this symbol. You must be substitute by the battery. Okay, positive on this side and negative on the other. However, if they working like normal, then you must be substituted by the battery here. Okay, positive on this side anode and negative on the other side. That's a very, very important. Okay. Let's see, I share on the other, okay, to make it better. This is an example. Last time we already did it. Okay. When you see the circuitry with the Zener diode, first thing is, this is Zener voltage is 12 volt. Okay. So any voltage higher than 12 okay, at this point, then they will be cut it down to 12. So now, first thing you have to know what the voltage here. In order to know what you need to do, look like we remove that Zener. We don't have a this signal. Then what voltage here? How do we know?
Use voltage divider.
Exactly. You're using the voltage divider. Okay. I can using iPad. I can using that plug here. Okay. And show you. Okay. That means you want to get the V out. Without Gina. Okay. Then V out equal 24. Okay. Time. Okay. RL divide R plus RL. That's what we call voltage divider. If you don't want to using the voltage divider, first thing you got the total resistance adding resistor here. You take the 24 volt divide total resistance, you get a current. And after you get the current, you multiply by RL. That's what you get the voltage. That's V out. So basically you get 24 volt, okay, 24 volt. Okay, time. R1 is 470, 470. Divide 470 load.
Mr. Fan, it should be 490 divided by
490.
Oh, 490. Okay. 490. Thank you. Okay. Divide to 470. Blood 490. Who get me answer equal what volt? Time
I get 12.25.
490.
Yes, I agree, 12.25.
Okay, what minute? Okay,
Same here.
just a minute. $490.
You're typing in the wrong place, Mr. Fan.
Okay, 490.
Yeah.
Okay, divide. What you get?
12.25.
Okay, 12.25 volt. Okay, now,
Mr. Pham, for the people who are new learning, take that 90 out before the 490 inside the parentheses.
yeah. Okay, without the Zener. Then the voltage Vout 12.25. Is it higher than Zener voltage?
Yes.
Okay, so that means when you get the Zener, the Vout only equal 12 volt. Okay, so with Zener,
Whoops, Mr. Pham,
how come?
you didn't move the cursor to the end and then,
Okay, with Zener. Okay, so Vout equal 12 volt. Okay, that will be breakdown. Okay, so now if you get a question, they say we are with down. Okay, Zener, they will be 12.25. However, with the Zener, they break it down, so you get only 12. Okay, so now if you want to calculate the current flow here, how? Current through R.
-24 minus 12 divided by R.
Okay, equal 24 minus 12, right? 24 minus 12. Divide
Never mind.
470, right? Okay, what you get?
25.5 milliamp.
25.5 milliamp. Okay. If you want to calculate the current for load resistor, okay, current through IL equal
VL divided by RL.
12 volt divided to 490, right?
Yes.
490. What you get?
$24.5 milliamp.
Okay, 24.5 milliamp. 24.5. Okay, milliamp. So if you want to calculate the general current, equal
1 million.
IR, right? I of R minus I of L. So you get 25.5 minus 24.5, right?
Hey, Mr. Pham, a quick question. The I of R and the I of T is the same thing, right?
Exactly.
Okay,
So 25.5 minus 24,
1 million.
1 milliamp. Okay, so that is normally you have to do all of the calculation for that type of circuitry. Okay, and now you get any question related into the problem we already showed you. The thing you will have to do in the quiz. So that's why guarantee you know how to do it.
and that current was 25.5 minus the 24.5, correct?
Right.
Okay, thank you.
Now, I've given you that thing here. Okay, given V0 equal 10 volt. Okay, and I have to do the same thing. You need to do calculate what? Okay, V out. Calculate the current I. Okay, current IL and current IG. Okay, what can we do? So now, normally, when you get a genome, you have to suppose you remove the genome and calculate the VR without genome. And we already did it. Without genome, VR equal 12 volt. 12.5.
12.25.
Okay. Oh, 12.25. Okay. So in this case, 12.25. I'm sorry, I can get one. I can get given VG equal 15 volt. Sorry. Okay. So the 15 volt, then without Gino, no Gino. then V out equal same calculation. Okay, 24. Oh, not 24. Now we change to 15.
No, it's still 24. It's still the same fee.
VG, okay. Still 24. Volt. Okay. Time 490.
Escape.
490. Okay, divide.
Bracket.
Okay, that will be 470. Plus 490. What do you think we get?
Same 12.25.
Okay, so you get the same 12,490. You get the same for 12.25.
0.25.
Okay, now,
Which center
what happened for the Zeno?
is normal.
So if I can that to be a 15 volt Zeno,
Yeah, it's not in breakdown.
they break down or not.
No, it's not in breakdown because
That means Zeno not break down.
so it acts like a normal diode.
Exactly. Not break down. Working normal. Okay, so if they does not break down, that look like you don't have a Zeno in that circuitry. Okay, so that means if you want to calculate the current, then you take the 24 divide 470 plus 490. Okay, if you want to voltage divider to calculate the V out. Okay, so if they asking the current Zeno, they're supposed to be 0. Okay, so they just working, you know, without the Zeno here. So if you want calculator I, okay, that means either you can do you know the voltage here, then you take the 24 minus that V out divide by this resistor, okay, and no current will be through the Zeno. That means they working like normal. Okay, now I can 24 volt. I try to bring it up on the K, you guys will hit it. Then 24 volt. Okay, to minus 12 volt. Okay, so that will be a negative 12 volt. So negative 12 volt here, you can using the voltage divider to calculate the V out. That means without the zener here. Okay. So basically, you can get a negative on this side. Whatever voltage will be a negative. And the other side here will be positive. So the diode now turn it on normal. However, what the voltage here?
It's in reverse bias, so it's 0.7.
Exactly, but still missing.
Negative 0.7.
Negative.
Okay. Then you can say, then diode normally working. Normal. Okay, and V out will be equal minus 0.7 volt. Here minus 0.7 volt. Okay, so if you want to calculate the current flowing here, you can take the difference between the voltage here and the voltage here. Okay, divide by this resistor. Okay, and if you want to get a current flow to here, this is the battery minus 0.7 divide to 490. So that will be telling you all of the situation apply, okay, to the zener. I hope, you know, when you hit into any problem, you're able to do it. Okay, now, next one. They apply that the sine wave to the circuitry. You can see this is the sine wave. Okay. Now, when the input positive, okay, input positive, then what the output supposed to be? In here, they given you 5 volt peak, 10 volt peak to peak, and the VG equal 3 volt. So for sure you understand, no matter what, the voltage here will be higher than 3 volt. So that's why they cut it right here. Okay, so instead they go to the 5 volt. They cannot. They will be cut at 3 volt right here. Okay. Then when you get the input negative, so you get a negative on this side, minus 5. So the zener not break down. You see that? The thing is that is a negative 5. And this is the round. So the zener turn on like normal. And when they on normal, this side positive, this side negative, and this side positive. That's what I already showed you at the beginning. So the V out will be equal minus 0.7 right here. So that will be telling you to get a sine wave applied to the inner circuitry. Okay, the voltage higher than breakdown 3 volt. So they cut, the output instead 5 volt. Now they get only 3. However, when you go to the negative cycle, that means you get minus 5 volt right here. And this the other side will be dropped. Just working like normal. And the voltage V out will be equal minus 0.7 volt. If you get a
Question.
yeah,
So on the negative side, since you got the minus 5 volts
right,
on the cathode and the anode is, if it's at ground, it's at 0.
right.
And 0 is more positive than the negative 5. So that's why it's a forward bias. And it would be, but I don't get why it's got the negative 0.7.
Okay. Again, I'm only telling you, when you get diode, they turn it on. Okay. Then this side positive,
Right,
this side negative,
right,
and the value 0.7.
right.
So that's why V out is negative. The battery right here,
Okay.
negative on the up. Below that will be positive.
Oh, I see what you mean. It's a battery and the top portion is the negative part and the bottom portion is the positive. Okay, I get you. Okay. Thank you.
You're welcome. Now, on the other one. Same thing. If you can see, now the inner connect this way, going down. So when you get a positive, that means when you get a positive here, okay, 5 volt, they not break it down. They just on normal. And when they on, this side will be positive, this side will be negative, and the value 0.7. So that's why you can see here.
Yeah. Mhm.
When you get to the negative cycle, that means you get a negative here. Okay, that means this will be minus 5. Okay, and basically they will be greater than, okay, minus 3. Okay, the thing is positive on this side, negative on this side. When they break down, remember that when they break down, this side will be positive, this side will be negative. So you can get okay, minus 5, and this will be minus 3. Okay, so basically they break it down. Okay, and that's why you can get output will be minus 3 volt. Okay, on that one, same thing. That means you get to 0. So positive will be turned on, this guy, break down. And negative will be break down, this guy. So that's why signal coming out will be VG plus 0.7. The thing is, one breakdown, the other will be on normal. Like we already showed you. If you don't have a this zener, using the first one, then they will be get breakdown. However, now you're adding another zener here. So when you get a positive, you turn this guy on. So that's why they can get 0.7. And the other part negative doing the same thing. Okay. Just for you guys to look into it. Okay, they want you to draw. Okay, I cannot draw here. So you say look like that one here. This is the output. Okay, so basically 10 volt here. Okay, so 10 volt here, 5.1 will be breakdown. Adding to 0.7, that's why you get 5.8. When you get a negative cycle, the top breakdown, so you get 3.1, 3.3 volt, minus to 0.7, this guy turn on. That's why you get
No, 3.3 plus 0.7.
minus 0.7. 3.3 minus 3.3. Minus,
No, 3.3 plus 3.3 plus 0.7 is 4.
no,
It's two negatives.
have to be minus 3.3. Minus 0.7. That's why you get minus 4. Okay, if you're looking on the output here, the top die zener or the bottom zener, which one break down? If you're looking at the output here,
The
remember,
top dial said breakdown.
3.3.
that one, exactly. First one is breakdown. However, you remember the zener diode here. When they break down, you substitute by the battery. That battery will be positive on this side and negative on the other side. That's why you get minus 3.3. Okay. Then this one is just turn on normal. Normal, that means 0.7, but positive here and also negative here. So that's why they're adding up.
And a 3.3 and a 0.7 gives you 4, but it's a negative 4.
Right. If you say for the correct calculation, you have to say minus 3.3, minus 0.7.
0.7. Yeah, I see what you're saying.
That's just the opposite, okay? We don't want to go. You can get time to look into that. Okay? Dye admitting diode. That means you can see that light admitting LED. So when they on, you see they turn red or green or whatever. Okay? And this just a sample for you to looking into that. Okay? This is LED 7 segment. This is a 7 segment. That means they can display number. They can display character. Like if you display the letter A, you turn off diode in D. Okay, and now you can see they turn on off the segment. Each segment inside they just have one diode. At it, they turn it on, they turn it off. And now you can see on this display here, they display number 8. That means all the diode will be turned on. Okay. This is just the information inside. However, to turn it on, turn it off, when you're doing in digital circuitry, okay, you can working on that. Okay. The next one, halfway rectifier. So basically, when you get the sine wave coming in, and the output will be look like that one. My question is, this is the AC circuit, AC signal, sine wave. So what is the signal here? What is it?
A DC pulse.
Exactly. First thing, they cannot be AC. Okay. The thing is the AC, they will be positive and they be negative. Okay. That means the current will be flowing left to the right, then the next will be a right to the left. Current keep changing. However, on this one, when you get the current, they flow from the left to the right. This is no current, not big deal. However, if you get the current, they still flowing left to the right. That means one direction. That means DC. Okay. However, this special only they call a post DC. Okay. This coming out from rectifier. So going back to the basic definition for rectification, what is it? Rectify or rectification, converting AC signal to DC signal. Okay. However, if you're looking on the DC, they support you only one line. Okay. Only one line. Straight line. If you're looking on the scope, they say 5 volt. That means 5 volt. However, on this one, they're not straight DC. So if you want to make a completely a DC, like just a one line only, what can you do? Normally, you can see the DC, they just a straight line. They not go up and down like this one. However, you can converting that one to DC completely. How can we do it?
Capacitor.
Who get any idea?
With capacitor.
Exactly. I can tell you, they put a next one will be a capacitor. And they get the charge time longer than this charge. So that means they charging up and they don't have enough time to discharge. So they will be built up on the capacitor. That's why you can get only 1 voltage. Okay. That's more detail when you try to deal with the power supply. However, halfway rectify, that means in this one, they rectify on positive, not negative. You understand a cycle will be from here to here. That's a 1 cycle. And they rectify only positive, not negative. So that's why they get the name halfway rectify. Okay. Okay, now that's what they given you a little more detail. Okay, just basically not circuitry, telling you how they convert it. You get AC right here. They go to the rectify, and they need a filter here, and that's why you get a 0. Okay, and the voltage DC right here. So how come you still get something here? What is it?
The noise from the 0.74. It's the noise.
That will be called a ripple. Okay, that means the time for the capacitor discharge and charge. So they still get some, not completely. Okay, so that's why you get the DC from 0 up to here. On the top of the DC, you can get AC, ripple. Okay, and then they need to go to the regulator, try to clean it up. So that's why now there will be a DC here. Okay, so anyway, this is just a rectifier. They converting sideways AC into the DC. Okay, either full wave rectify or half wave rectify. Okay, now you can see this circuitry here. When you're doing MSIM 7, you will be see they will be the same. Okay, so you apply sideways here to the circuitry. So the positive turn on the diode. So you can get this part coming out. Okay, and from 0 to here, that will be VP. Remember, they given you this with the ideal diode. That means you have a no VD. VD equals 0. So that's why they start from 0, go to VP. So when you go into the negative cycle, diode will be open. That's why you get 0 volt. Okay, and you keep going. The output will be look like. Okay, and the question is, what the frequency? Okay, between the input and the output. See, they say output frequency, input frequency will be the same. That means if you get a 1 kilohertz here, output coming out will be 1 kilohertz. Okay. Now, also they mention here, for second approximation that normally you're working on, and diode when they turn it on, they will be 0.7 DC. Positive on this side, negative on this side. So that's why output we pick, they not equal completely what you see right here. Same exactly, no. They will be also including minus 0.7. That's for second approximation. That's what normally you're working on. We're not working on with the ideal diode. Okay, next one, transformer. What we're using transformer for? What is a transformer? When you're looking on this thing here, you know this what they call a transformer. Basically, the definition, transformer just converting one voltage to the other voltage. Okay. That means you can see outside, they can get a 3-wire, 240 volt. So they go to your house, they need 120. So they need a transformer. Okay. They converting from 240 into 120. And now if you read it, transformer transform one voltage to the other. Primary voltage on this side we call a primary VP. On this side we call a secondary VS. Okay. VP is the primary, VS secondary, and P, that means right here, and P and NS, NP, that is the number of turns in primary, and NS, that number of turns in the secondary. So you can get the formula NP over NS equal VP divided to VS. That will be telling you, if you want to calculate the secondary voltage, you can take VS equal NS times VP divide NP. And in here, if NP higher, NS higher than NP, that means how many turns the wire on NP or NS. If NS higher than NP, transformer step up, that means you can get 100 volt primary. However, go to the secondary, they can go up to 300 volt. That means step up, okay? If NS less than NP, step down. That means you get 240 volt here. Go to the transformer, they going down 120. That's what we call a step down. The thing on this thing, we don't have a much thing, you know, to go into too much detail. The thing is that not need for the technician. Only thing you see the symbol, you know, this is the transformer. Which one is the primary? Which one is the secondary? How many turns for the primary? How many turns? That means the wiring. Okay. For the secondary, then you're able to calculate the secondary voltage. Okay, if you know primary. That's just a very simple. Okay. Now, you're looking into this circuitry here. halfway rectifier. They given you this circuitry. Okay, they want to see the peak secondary voltage. Now you get 156 volt and ratio between primary secondary 2 to 1. So if you want to calculate the V secondary, then they will be equal to what? 156 times and add, that means 1, divide NP 2. So basically you take 156 divided by 2, you get a secondary. Okay. The peak secondary voltage, V peak. Okay. You can see that will be a 156. That's the peak voltage. Peak to peak, they have to multiply by 2. So the peak secondary, you take 156 peak times 1, divide 2. The rectifier peak output V out. So the output V out, remember, we're using second approximation. That means you can see on the display, they can get minus 0.7 volt. Okay, when I can go back to this circuitry for the signal when I fix my next time. If the input frequency 1K, what is the output frequency? Again, halfway rectify, input frequency, output frequency will be the same. Okay, after this one, we will stop. Now, you're looking on this one. The name, HalfWave Rectifier. Is that HalfWave? Why HalfWave? The thing is, output positive, they also rectify. Input negative, also they rectify. That means they rectify both positive, negative. So that's why they get a HalfWave rectifier. Okay. For this circuitry, they're using the transformer. Same thing. However, the difference is, you see, in the middle right here, they connect it to route. This transformer, they go send the tape transformer. So that's only telling you when the V primary, they go to the output, they divide two signals here, one on the top, one on the bottom. They the same value by the secondary divide by 2. Only thing they opposite. If this positive sideways, this will be negative. Okay. So that's why the diode, okay, when positive, this guy will be on. You let positive go. When the negative, this red here will be on. Okay. And also you can get a sideways coming out. That's why they go up. HalfWave rectify. In the HalfWave rectify, okay, I don't care about DC ever. However, frequency, the frequency at the output, frequency of the input from here to here. The frequency of the input from here to here. That means the output frequency equal double input frequency. If you get a 1 kilohertz input, you get 2 kilohertz output. And also they remember ID of M equals 0. Okay. Right now they draw from 0. If second approximation, they will be going down here, not right here. Okay. The thing is you still get 0.7 volt. Practical diode, VD 0.7. Okay. And VP out will be equal to VP in minus 0.7. Okay. Next time, okay, we will go a little more detail for you on this thing. And then this one a little more detail, okay, on same thing, full wave rectifier. Okay. Now you can get this the primary. Okay. And this is a center tape transformer. They divide the signal on the top and the bottom, the same value. Okay. The half value of the secondary voltage. If you get a secondary voltage here, divide by 2, you can get this voltage. That's what they say. V secondary divided by 2. However, you can see the difference. When this positive, this will be negative. The thing is they draw right here. Okay. And if here, negative, output positive. So that's why when they positive, they don't turn on this guy. When they negative, they turn on this guy. Okay. When they negative here, they turn off this guy. When they positive here, they turn on this guy. So that's why they will be coming out both positive and negative. So that's why they call full wave rectifier. Okay. That will be given a little more here for you to read. Same thing. Okay. Now I quickly telling you that one. That's a full wave still. Full wave. Okay. That's how the full wave look like. Okay, last one. We'll be talking about it next time also. Now, that is, if you're looking into the circuitry, the output here, same full wave rectifier, exactly the same. However, only thing they only using 4 diode. Okay, and also the transformer here, not the center tape transformer, just normal. Okay, so the reason they don't want to using a center tape transformer, that costs too much. Okay, if you're using normal transformer, it's much cheaper, and you're adding only 4 diodes. Diode maybe 5 cents, 8 or 10 cents. So really cheap. So that's why most of the full wave rectifier, they prefer to using what they call the bridge rectifier. That means working they exactly the same full wave rectifier. Either you can using center tape transformer, or you just using 4 diode. However, for the using 4 diode, they using different name. It's the bridge rectifier. but they working same thing. Okay, that's just more detail. I just get through it and explain to you next meeting. Just a break, okay? Now, after this chapter, the next chapter will be learning about transistor, okay? So we can spend this Friday for all of the thing, try to cover for the first chapter, that means for rectification. Okay, remember, you can get diode, normal, how they working, Zener diode, how they working, then you can go into the half-wave rectifier, full-wave rectifier, and the bridge rectifier. Guarantee you are able to understand. When you look into the circuitry, you're able to tell exactly the name. Is it a bridge rectifier or full-wave rectifier or half-wave rectifier? Okay, and also, you know, you can tell what the output supposed to look like, but we not go into the detailed calculation. Okay, the thing is when you fix the circuitry, you just take a measure, compare to what they wanted. Okay, you don't have to do calculation. You're working on the circuitry, you want to fix it, you run the program, they telling you apply input, output, measure at the output, what they want. They want sideways, how many volts, peak to peak, what frequency. That's what they telling you they already wanted. Only thing is you measure. You cannot what they wanted. That means something must be wrong and you have to fix it. Exactly the same thing. When you're doing left volt, what happened? First thing they say, build circuit. That means you have to using the 2-pole or the jumper. Connect the real circuitry, exactly the circuitry they want. And after that part, second part, they say, apply input sideways 1 kilohertz, 5 volt peak to peak. Then you can measure the output. If you enter the value you measure, if it's good, they say correct. Otherwise, you can see they turn red, incorrect. Now, in this incorrect, what can we do to get that done? That's what we're talking about, troubleshooting. Okay? And I'm sure I will be teach your guy how to do it. More and more time you exercise, that will be get a very good skill. How to isolate the problem, how to find the problem. Okay? So anyway, any question up to that point?
Mr. Pham,
Yes, sir.
I was wondering, is my name on the list yet?
Can you say again? What?
Is my name on the list yet?
Oh, your name on the left phone, right?
What?
Left phone display. Okay.
Yeah.
You can see right here. I
Can you show it to me?
Yeah, I say again, okay? Just a minute. I can share for you. I already telling you. Go to the website. Okay, go to the website here.
Hold
Go
on.
handout. Here, left phone in class schedule September 28th to 30th.
Hold on. Hold on. Which,
Okay, so you can bring it out, you want it, you can look into here to see what your name and what circuit board supposed to do. What system number, same thing.
huh?
Okay, I go back, okay, to telling you how you get this one.
Yes, which tab do I have to go to?
Okay, you know how to go website here.
Yes, I know that one.
Go to click on handout.
Handouts. Hold on. Let me just. Got it. Oh, I think I see. I think I see what you're talking about.
Click on handout, right?
Yes, handouts, lab volts, in class,
Yeah,
schedule.
click on that.
Uh-huh.
Then you can see.
Okay, thank you.
You're welcome.
I get it now. Thank you.
Yeah, the thing is right now, normally weekend, I report the schedule. If you guys
Uh-huh.
not see your name in the schedule and you basically, you know, you qualify to get in
So-
that.
So if I'm not, if my name's not on the list, I'm not in the class, right?
Yeah,
Okay, thank you.
so if you know you already qualified to go into the class, but you didn't see your name, you can email to me or text to me.
Okay,
Then
thanks.
to working on, okay?
Uh-huh.
The thing is,
Thanks.
more and more students can get into the lab.
Mm-hmm.
I hope
Mm.
next semester they clear everything, not just go back to normal. Otherwise, I really get tired with this thing. Take too much time.
Thank you.
You are welcome. Okay, any more questions? Okay, if it's not, we'll see you on Friday.
Just to clarify, if my name's not on the list, oh, sorry about that.
I don't know. You see it.
I'll go look for myself.
Yeah. Okay, so good night, everyone.
Good night, Mr. Pham.
Good night.
Good night.
Sorry about my iPad. Gave me trouble.
Okay.
It's okay.